On this episode, Scott and I welcome Vincent Zimmer to discuss his career in firmware, UEFI, and some of his over 450 patents. Stay tuned for this edition of Eclipsium's Below the Surface. This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network. Welcome to Below the Surface, the Firmware and Supply Chain podcast. This is episode 6 for March 22nd, 2023. I welcome my co-host, Mr. Scott Schefferman. Scott, welcome.
Hey, thanks for having me again. This is always fun.
I feel like we got like an upgrade. Like we're doing it from the studio, and we've got all kinds of like intro music and stuff like that. It's good. This is our first one from the studio, so hopefully everyone will continue to enjoy as we get started on episode 6. Our guest for this episode is Vincent Zimmer. Vincent works for Intel Corporation, where he has been employed since 1997. While working at Intel, Vincent has received his master's degree in computer science from the University of Washington and is presently a senior principal engineer at Intel. Vincent has received over 450 U.S. patents and presented at several industry conferences. In addition to the Beyond BIOS book, which I have, which is awesome, by the way, Vincent has published several book chapters, papers, and articles. Along with writing firmware, Vincent has also contributed to and written specifications in the Unified Extensible Firmware Interface Forum, the Trusted Computing Group, and the Internet Engineering Task Force. Vincent, welcome to the show.
Hey, thanks. Thanks for the invitation. And yeah, I'm excited about being in the office here.
Nice.
A lot of these meetings, you would sometimes have cats be cat bombed in the middle of a video call. Right. So, if I see a cat here at the Intel office, I'm going to be a little worried.
That's right. Oh, that's awesome.
Especially a black one.
Vince, how did you get your start in like firmware and firmware security?
So I've probably been, I think my first job was back in 92. Back in Texas, I worked on embedded systems, firmware, sort of process control. A couple years later, got into the sort of PC industry, industrial PCs. That was kind of thematic down there in Houston. And then joined Compaq. And Compaq was where sort of mainstream computing sort of got my dip into that. And then from there, I was recruited by Intel in late 96 to work on their 64-bit Itanium. Joined Intel, and part of Itanium was we had to figure out how to reimagining booting the machine. And that's where things like EFI came about. So joined the EFI team in 99, and my focus area on EFI was included networking and security. And so since I would guess 99 is where I sort of dipped my toes into security, and it was all about what should we do in EFI. And then in 2000, we embarked on a journey at Intel to sort of reimagine how you might build a BIOS. And that became this project codenamed Tiano. Mm-hmm. And so that's kind of where I jumped into security, both what do we do for the EFI as a standard, and then the underlying way to build the BIOS via the Tiano initiative, which is now realized as the EDK2 code base in the open source. EFI became the UEFI forum, which includes the main UEFI spec and then the underlying PI spec. And then the attendant standards work I did along the way were, where EFI touched trusted platforms. So I worked with the Trusted Computing Group to say, hey, this is how you can do EFI stuff with TPMs. So late 90s, EFI, and then what do we do for security in EFI, I guess would be my origin story.
The move from BIOS to UEFI, security wasn't the only thing at play there? Was it a major driver? Like what role did it play, and what was more of the reasons why we moved from BIOS to UEFI?
Yeah, and I think judging by the arc of some of the features, you can see security wasn't top of mind. It was kind of a friendly world. What was our security concern? The CIH virus overriding people's flash. So no, the big reason was Titanium. One, we couldn't boot the EFI way, and so we looked at open firmware, ARC, and for various reasons, telling everyone to write F code, or the ARC spec was kind of a weird spec. We had to figure out how to boot Titanium, and then we said, now that we have this and it's written in C, we could probably do it on IE32 because this was before 64-bit, Intel 64. And the big issues were legacy BIOS assumed a 16-bit execution environment, making int calls, loading that 200-byte master boot record off the first cylinder, disk size limitations through MBR partitioning. So EFI with the GWDed partition table gave you unbounded disk size. The EFI OS loader allowed you to be kind of architecture neutral and then crush the 200-byte limit. So it was really, how do we be cross-architecture? And then some of the business drivers that said, why change my legacy BIOS, were bigger disks and a better OS load experience. And so that was kind of some of the motivation. But until Microsoft said, go required EFI in Windows 8, it was always a struggle. So what we did to mitigate it was we would build this, modern BIOS, an EFI style BIOS, like through this TNO, EDK, platform initialization spec thing. But we always encapsulated what we call the compatibility support module, or a CSM runtime, where we could boot the MBR way. We would keep a slug of 16-bit code around where we would initialize the machine in, say, native 32-bit, and then jump to 16-bit for OS compat. And then we've been slowly removing that over the years. Because I think even Windows 10, the ISOs still have an MBR boot, the legacy boot capability. But with Win 11, it's pure EFI. That tells you how
I remember doing that a lot with Linux too. Before Linux had UEFI support, doing the compatibility mode.
And it's wildly consistent, and it paid the bills for the PC ecosystem from the early 80s until maybe circa 7-8 years ago. So standing on the shoulders of greatness, the folks that did BIOS, I never would decry legacy BIOS. It just EFI helped solve some problems of cross-platform. And then of course when the ARM guys rolled in, they said, I just have to add a few paragraphs to the EFI spec, tell GCC I have a new architecture type, and so ARM was able to embrace it, RISC-V now, and so as any standard, once you do abstractions appropriately, you enable a lot of different capabilities, and so now like Windows on ARM boots the EFI way, etc.
So I've always had a question for a lot of our audience. They don't understand how the operating system gets to talk to the UEFI and what those connections are that kind of flow downwards, if you will, compared to pre-EFI. Do you have some thoughts there in terms of why that was needed for just usability purposes and whatever?
Right. That's definitely a good question, because sometimes, I don't know about you guys, when I look at a design or standard or something and think, wow, there was some great visionary that laid it all down on day zero. Instead of that, often things get accreted over time based on people's circumstance. And so EFI runtime is definitely an example of that. So in an ideal world, you'd have these nice handoffs, right? Phases of execution. Like if I turn on the platform, jump to the UEFI loader, I have this very stylized call called exit boot services that says EFI owns the machine, it manages the hardware. At exit boot services, Mr. Operating System, you own the hardware. On PCAT BIOS, when you called int19, it was never clear of when BIOS stopped doing stuff and when the OS took over. So EFI had this great line. Maybe the less so great line was parts of the EFI environment still hang out, called our runtime services. to get the time, set the time, get a monotonic counter, set and get these things called UEFI variables. And a lot of these actually were driven at the time by Microsoft for the OS installer experience. So EFI is a bootloader manager that says, hey, what do I boot? And so it maintains these policy objects called UEFI variables that tell the firmware, where do I find my operating system loader? Kind of the reason for existence of EFI as an interface spec is that. And at the time, some of the Windows guys said, man, it'd be easy if we could have an installer and post-exit boot services through our cool Windows console call into the firmware and say, set these variables. Correspondingly, it'd be cool if we could have an abstraction for the time. This is in contradiction to the other trend, which is at runtime, the predominant way firmware talks to the operating system is a co-pending standard in the UEFI forum called Advanced Configuration Power Interface. An ACPI are a set of tables, static tables, and an interpreted bytecode called AML that the OS can sandbox that at runtime tells us what the hardware looks like, how to manage power. We're big fans of ACPI because it can be sandboxed. UEFI runtime is kind of tough because it's native code from the firmware, but we don't own the hardware anymore. But it was really driven for usability, as you rightly mentioned, based upon some of the original Microsoft architects. And I thought, man, that sucks. We made a mistake. And so I remember when the ARM guys were going big on EFI, I talked to Leif Laidholm and said, this UEFI runtime is so painful, how do we manage this one piece of hardware, i.e. our variables, while the OS owns the rest? And he said, yeah, but it's so useful. You go to sysfs, EFI. So it's a usability versus security thing where usability was the predominant driver for this small set of UEFI capabilities at runtime. And it harkens back to the original EFI spec in late 98, early 99. So it's legacy in a sense. We have our own legacy, I guess. It's relative to. That's why I can't call it legacy BIOS for PCAT BIOS because it's just different timelines of legacy, I guess. But that is a legacy of the original EFI design decisions in working with the OS vendor.
Now, Vince, you were there at some of the early times when we started to consider. I say we, largely Intel, probably Microsoft, started to consider we need a secure way to boot the platform. But did it start out as measured boot?
Yeah, so I think a lot of boot security, boot integrity. I think a lot of the thinking in the early 2000s were, I think Microsoft had an initiative called Next Generation Secure Computing Base. Intel had Legrand technology, AMD Presidio, where adding sort of capability in your CPU to say at some point go into a high integrity mode through a new instruction. And then that activity would be recorded in a trusted platform module. So the TCPA, what became the Trust Computing Group, came up with the TPM as a way to record going to this, verified mode. And then there was CPU evolution. It turns out, virtualization-based security and such that we now see, really going big in the market with Secure Core PC didn't gather that momentum in 2000. And so what I think Microsoft did at the time and said, hey, we have this TPM that was for this, these new, sort of dynamic roots of trust. Let's use it for a use case, data integrity. And then they came up with the BitLocker feature. And so BitLocker is all about if your machine's in a given mode, you can unseal or decrypt the volume key to decrypt your disk. Well, for that scenario to work, somebody has to fill in the TPM to tell you what state your machine is in. And that's where the BIOS guys came in. We had to record both for legacy, PCAT BIOS and EFI, record the data and code execution up to the OS loader into a TPM, a trusted platform module. So I was the EFI guy figuring out how to make that work. Work with Microsoft. We got BitLocker going on EFI, Circa Vista. And at the same time, Microsoft said, man, all this code in Ring 0, how do I know if it's good? And so in Vista, there was a feature they had called Code Integrity, or CI. And what CI was their OS loader, both for legacy boot and EFI boot, would cryptographically verify the early boot and kernel drivers. So they really had a nice story where their trust anchors were started with their loader. But the problem they had was, how do you know if the loader is authentic? Meaning, the loader, you can't establish your own security out of, thin air or bootstrap yourself by your own, or whatever the saying is.
Like the root of trust has to start somewhere, right?
You got it. It was like a gap. It was like CI started in space. And so I had been doing the measured boot, and I thought, man, I work with Microsoft. What a weird way I have to hash the EFI image, their loader. It's a format they call Authenticode. Skip the date time, skip the security section. And it turns out the hashing for a TPM is a digesting process of verifying boot, meaning you hash something and then you verify a signature across that small data set, that SHA hash. And so I said, that's Authenticode. You guys should probably publish that. And then working with Microsoft in the UEFI forum, we said, since CI sort of starts itself, and you're a PE-COF image, and we're already loading you as a PE-COF image, meaning what CI does for Windows kernel drivers, we could do for the Windows loader, meaning we grok the PE-COF image. Hey, Microsoft, just publish your security section, how you validate yourself. And if you make it public, we can add it to the standard. And so at the time I was working with Microsoft, I said, why don't you publish it? And they said, well, we got a scan of some 10-year-old doc here. So they had to write a doc that explained Authenticode and how the security thing worked. And I said, cool. If you make it a spec and you document and you donate it for the forums, the standards group work, we can then correspondingly write code. And then we said, okay, we now know how to hash and crypto verify it. What's the key we use to validate the OS loader? And that's when we said, maybe we can come up with a new kind of EFI variable that's more secure. We call authenticated variable that keeps a certificate that the OS guy can put in firmware. And we validate the image. And oh lordy, managing those keys and securing those variables, if there's Adam's original sin of 2006, it's been the challenge for the past 16, 17 years. But that's kind of the origin story. And then at the same time, there's a class of attacks we knew called bootkits, like the Stone bootkit, where people could replace the master boot record with attack code. And how would you ever know? So a lot of vendors had proprietary mechanisms to store hashes of MBRs. But writing an exploit in 200 bytes, you had to have some serious systems programming foo.
Yeah, that's for legacy BIOS.
For legacy, sorry. Yes, for legacy, the loader was like a 200 byte little chunk of code, first stage loader. Whereas for EFI, that first stage loader is now a PE-COF executable that we published a bunch of SDKs to build. Would be trivial. I used to joke the EFI developer kit was going to become the shellcode developer kit if we did something. So in the same time of helping solve the business problem of Microsoft CI could go back to a root in the platform, I was always arguing the extensibility of EFI was that double-edged knife. It's great for the supply chain to write code, but then your attackers can easily write code. And so putting some owner control around executables, now not just the OS loader, what about those EFI drivers and adapter cards you plug in? Let's apply the same policy. So it really was a confluence of events. When we did measured boot, realized we were halfway there. Microsoft did CI and realized they didn't have anything underneath loader-based. They're having a root just based in their loader. The unbounded extensibility of EFI being the sharp edge of the knife, unless we did something, all kind of came together in 2006. I was in Vegas for Black Hat, and John Heisman did a talk on how to break ACPI 2006. And so that was like, yeah, okay, we need to tighten it up. That's an OS guy thing. He can sandbox it. And then 2007, he said, this EFI is cool. The original spec's vague on security, and man, people are going to hammer platforms unless they do something about, this unbounded, unvalidated image execution. So give as much credit to Heisman, Microsoft, and a lot of people in the industry that we all kind of bumped into each other at the same time in the mid-2000s around this.
Can I ask a question? This is a question that you rarely get insights into from someone like yourself, but what you've been talking about is being able to validate the integrity of these things, right? But to what extent does Intel and Microsoft traditionally or historically, I guess, worry about an actual vendor putting something that's signed and trusted and validated throughout this process? but may have its own malicious code. Because that root of trust ultimately seems like it goes back to nothing to do with whether something's malicious or not, but only that it comes from the vendor and you can validate it hasn't been changed.
Sure.
Right?
Yeah. No. I think that's the insight. And if I had, and most of this talk, I should have given the preamble. I'm wearing my standards hat. If I were given my Intel official spokesperson hat, I would see that big candy cane hook just pull me off the screen. So I'm talking from open source and standards. So yes, and in fact, I have people that rebuke me a lot because people conflate secure boot with security. And in fact, it wasn't even supposed to be called secure boot. That was a separate section of the spec that people, you never say secure. It's like hit me, right? Put a hit me sign on. So it's all bad. But no, you are exactly right that really signing just shows provenance. And so co-pending with this work, can people have either malicious or inadvertent flaws? And that's where Microsoft, as the UEFI CA, has a vetting process. It's how they inspect the code. You'd have to have them speak first party on that. But the other thing on the defender side is I assume it's attacker. Everyone's an attacker, right? I want to ship a platform and I want to maintain, quote, the integrity shape of the platform. So advocating and driving a lot over the years, more defense in depth. So assume the image has a flaw. So do you have stack canaries? Can you do control flow? Can you do ASLR such that if they get in, can you contain the damage they do? The problem, of course, is compat. So we did EFI 98, 99. We're all boogieing in ring 0. So like in 2015, when I started pushing DMA protection, I said, we got this. I've always had the philosophy of, I got this modern CPU with all this cool hardware, MMUs, IO, MMU, regular MMUs, light up all this cool gear while I own the hardware during boot time and defend myself. So I said, okay, turn on IO MMU. EFI spec has a call that if I'm a device driver and I need a buffer for DMA, I make a call. I'll just hook that and say, if you ask for a buffer, I'm only going to censor the memory map that you get the one buffer to DMA into. Well, it turns out on x86, since we're cache coherent between IO and memory, people were just allocating pages for DMA, and it worked. So when we tried to retrofit the IO MMU, we broke a bunch of people.
Oh, because they couldn't live. They basically couldn't live within your constraints.
Right, exactly, and we're having it again. So circa now, where a couple of years ago, Keith Cook, the Linux guy, he on Twitter said he saw the latest EFI exploit boot hole. It was probably at the time, and said, "Dude, we've had PACs and all this protection for 20 years. Are you EFI guys sleeping?" And I said, "No, we're not sleeping. Maybe we're not always the most awake, but we're on it." And I gave him a list of our protections we're doing, the NX and the canaries, and he said, "Great. How do I find a motherboard with that?" It's like, okay, that's a good question. Can we make it more software observable? That's a discussion we have with the industry. It's, how do you ensure the supply chain's turning it on? And then the other issue was, I told him, NX, if I want to turn on memory protection during the boot time when I'm running third-party code, I can do it. But what I observed was the Windows loader, it allocates a buffer, it puts data in there, it fixes it up, and it jumps to it, meaning it has its own image loader. So it goes from code to data. And so if I own the page table and I'm protecting the platform and a secure boot authentic image flips the code data semantic, how do I know? So we're working with the industry in UEFI 2.10. We added an API like mprotect in Linux to say, if you want to change policy and you're an official secure booted thing, you can. But it shows people have been rolling code for a decade and a half that assumed code equals data, such that when I try to do memory protection during the third-party extensible part of EFI, I break people, just like when I turned on the IOMMU 7 years ago. So, compatibility is great. I'd argue the EFI spec, we've maintained compatibility such that back to the original .98 spec in 99, that PECOF image will, quote, work. Well, boy, howdy, he may have been assuming some things that if I try to armor a platform in 2023, break, and then you make the business call. Do you say, I'm going to break people and be more secure? Or do you have setup options where turn off security and the first thing your attacker is going to do is go after those platforms.
But that's a hard. I mean, that must be a challenge in your career, Vince. Right? Is balancing the like what's good and what's bad. I have to provide this functionality, but some of that functionality can be used for good. Some of it can be used for bad. And how do you tell the difference with all these protections? I mean, you just kind of described some of those struggles.
Yeah, I think it has to be driven by the business, right? It's OS vendors, motherboard vendors, and as we even evolve to like, if you look close and do a dump bin on our like images today, you'll see they're signed with RSA 2048. Some SHA-1, you'll gasp, or SHA-2. And as we move to bigger RSA keys for some potential post-quantum hardening, how do you maintain compat? So what if the old firmware didn't support bigger keys? Do you now have a new OS that won't work on your old motherboard? Do you dual sign the image to say, here's a weaker signature and a stronger, so I can be compatible, but then people are going to go after those motherboards with weakly signed things? It's brutal. And my take is you always need to be humble. I always quote Bill Joy from Sun: the smartest people don't work at your company. So listen to the market. I'd argue some of the smartest people definitely don't, because Yuri and John now work for Eclipsium. So there's an example of Bill Joy in practice. But yeah, you just have to listen to the market. I'm a participant in the effort. I have a seat at the table, but I don't sit at the head of the table, and do what makes sense to balance business, usability, and compat is the hallmark of the PC. But boy, it's hard.
Yeah,
it's
and it's hard. I think it's hard too. One of my realizations was that you really rely on your upstream suppliers to fix things for you. That I can't fix a lot of these things myself. You mentioned a lot of the protections that are in there, how the UEFI process works. If I go, oh, that's not configured securely, I have to go upstream to get that, and this is a real big supply chain problem. Are there things we can do to kind of ease these fixes to come down, or is that really just up to the OEMs and AMIs and Phoenixes of the world, right, to produce the software? The manufacturers of the hardware all have to come together, and Intel too.
No, it's right on. And in my most popular infographic I show is how we have the upstream, like EDK2, that gets snapped to maybe how Intel builds a reference tree or another silicon vendor, but then a firmware vendor may snap the open source. An ODM may take something directly from the upstream or their firmware vendor, and it's a tortuous supply chain. But the positive, and it's all positive, right? Because we're technologists that are helping the world get better, is remove people's reasons for not doing things right. So the fact that we have an upstream implementation of Secure Boot, I was so happy, because I remember when we were doing the original Windows 8, one of the head validation guys at Microsoft would send me a weird PECOF image and say, what do you do with it? Because think about it, Windows runs on PECOF. They have to have seen every mutation and permutation and overlap sections and lie about the VAs. And since it's a very complicated, image formats are very complicated, had the world help. And I thought that was awesome. And then the servicing you mentioned, worked with the standards on this concept called capsule update, where hey, let's all have a well-defined mechanism to envelope or wrap your code, that it can be pushed through Windows Update as CAB files or the Linux firmware verification service. And then I worked with my teams to say, hey, we have a very diverse set of participants in the supply chain. We probably need to build like SDKs and packages and examples. Originally, that fell on deaf ears in the early 2000s. They said that's company's value add. I said, well, post NIST 800, 147, 193, it's a basic good having this assurance. I think we need to have an implementation that people can just grab. Don't put a test key out there, right? They still have to set up a hardware security module, but remove people's reasons for not doing, basic hygiene. So put some defense and depths in the open, put a capsule flow, and then the ecosystem, LVFS and Windows Update, Microsoft and the Linux distros have rocked it out, and driven, Red Hat specifically on LVFS, the one-man army there. And then our small part of it at Intel, wrapping with them in the standards group, and then contributing stuff to the upstream. And then the business drives it. security ISVs say, hey, that doesn't look good. Maybe you should update. Work with the trusted computing group others to publish manifests in the future that say, here are the expected hashes and such. Keep laddering up our capabilities and work with partners to say what makes business sense versus motion for progress, right? You don't want to add more tech debt or do security theater. We want to add real capabilities that address the problem. But I'm positive, and I think the supply chain has been evolving. In the old days, they say, oh, consumer laptops no one ever updates. I've had some consumer laptops now. I've seen vendors pushing updates more frequently, not just business. So I think it's getting better.
Yeah, is LVFS the step in the right direction for open source and firmware updates? I think in my opinion, the project is doing amazing. It seems like you have some familiarity with LVFS.
Yeah, no, I think LVFS is the right answer, and it's specifically because they've kind of generalized it. It's a framework for pushing updates, including host BIOS. But if you'll give them a plugin for doing updates of device firmware or what have you, they have the service. You can do it on-prem, or you can use the global one, the globally hosted. And I think LVFS is the right answer. And then I think from my engagement with the standards and open sources, what can we add to complement and support it? But I think the Red Hats of the world driving LVFS, the Microsofts of the world driving Windows Update are the right answer. And then folks in the hardware and systems business, OEMs, hardware vendors, engaging, but having the OS vendors drive a lot of this automation, specifically LVFS, I think it's definitely the right direction. And again, I'm glad it's more than BIOS. I'm glad it's not just a capsule update only thing, because the world isn't just host firmware. And in fact, I remember one talk, someone showed a motherboard and said, there's 16 updatable firmware elements. One is your host BIOS, a la UEFI. So
yeah, I think that's a slide in every Eclipsium deck, actually.
Oh, you guys have good. All right, maybe that's what's paging off disk here.
Yeah,
maybe but with off disk.
With open source firmware development such as Core Boot, is that like a positive thing for folks that want to continue to support older hardware? In other words, I can't get the updates because the OEM has sunsetted and is not supporting that, but open source might support that. Therefore, I can get these updates. I can get security fixes. Is that a valid use case to combat some of the legacy hardware security problems?
Yeah, and it's definitely a balance, and we're facing this like in the Open Compute project and others where hardware roots like BootGuard or AMD's PSP verified boot, where you blow fuses and kind of bind your early BIOS to the platform, kind of is challenged by this more open. Yeah. So companies like Star Labs or of course Chromebooks, where you can go into a developer mode and flash all the way down to the early boot code. That's kind of the structural challenge, i.e. building a platform such that an enthusiast or an owner can put their own BIOS in. But I think Chromebooks are showing one viable path, meaning if you go into developer mode, you can't get to the high valued services like Netflix on your Chromebook or what have you. But if they end service for the Chromebook, you could still update the BIOS on the motherboard. They upstream the platform code. There's open source OEMs like System 76 and Purism that leverage that. I think it's a positive, and I think we just need to find a balance between having hardware roots if you elect to have it, but then can you have for the circular economy a way that an alternate owner could remaster the firmware, and for certain markets that makes sense, for certain it doesn't. So yeah, the jury's out. So I sort of described the scenario, but I don't necessarily have an advocacy. As a technologist, I think some of the balances can be, if I had a higher fidelity way of reporting I'm open, such that people could then say, you're not doing hardware secure boot anymore. That's cool. You can run my Windows or Red Hat. I just won't let you access high valued services because your threat risk profile is different.
Right.
Maybe we make it more observable as being dictating one or the other is best. That's my view as a technologist, but me from the business, I think it's a work in progress, I would say.
Yeah. Scott?
So Vincent, just earlier you were talking about what I would just loosely describe as the massive complexity of this supply chain that you guys have to work with, especially. And because this is the below the surface threat report, I wanted to ask you some of your thoughts when it comes to, let me put it like this. We did some research called BMCNC, which was based on a leak of a lot of stuff from one of the very highest up suppliers. I don't want to mention names. I mean, it's public or whatever, but it's not really about that story. But one of the things we observed during our research that at least surprised me, right? I'm speaking for myself, is that there are a lot of keys and secrets and certs and whatnot stored that were both representative of suppliers upstream and downstream of the particular leak we were looking at. And when you look at like these ransomware actors that are extorting the IT supply chain, and a lot of them are these firmware developers right now, there's certain groups like RansomX that just hit those all the time. And they realize if they could leak that source code, it's a lot of leverage for them to extort money. So when it comes to leaks and kind of that threat of the supply chain, I was always curious, like, why are there so many secrets that you find? Is that a necessary evil of having to work up and down the supply chain to develop and build code that's interoperable? And like you have to provide secrets upstream in your case, right?
Yeah, I think assume your code base. Your threat model should always be assume your code base is always going to leak. People are going to look at what you have. So yeah, the actual having to distribute secrets, I don't think should be a necessary part. I think we provide tools that people can use, but in concert with their own HSMs and other infrastructure. It might be just expediency. It's easier, right? You always tell people, hey, never sign locally, sign use an HSM. But I remember a horror story when I was working with the Microsoft guys on UEFI Secure Boot. They said, yeah, this one vendor does it all. And if I say the country, people will know which vendor it is, off his laptop. And so if that guy gets hit by the bus, there's a certain class of adapter card that's not going to work anymore. He shouldn't be, but they do. So I think it's more accidents of expediency than requirements. I don't think the technology argues for it. I can't stitch my widgets together, but it also speaks to where I don't see all the layers, right? I see the kind of infrastructure Intel gives out, and we mostly give out tools. I don't believe anything, again, our ref code require, secret curation and sharing. But when you start building those successive layers of the stack and BMCs, which are full up Linux, and maybe, one vendor to a next, maybe firmware vendor, integrator, ODM, they may observe it's easier for some of those transactions to do that. But I don't believe the technology ever typically argues for having to do that. I suspect it's more from expediency is why it happens. And then given a lot of this isn't done in the open, who's watching the watcher, right? So you asked about the core boot stuff earlier. I liked how the Chromebooks kind of put more of their workflow in the open just because, it's more observable what's happening. So, but yeah, I never confuse evil, and not to say ignorance, but maybe lack of attention to detail. I don't believe it's evil either. It's just probably expediency. It's easier to do it. Whereas the best practices hurt. Setting up a Thales HSM isn't something I can do in my lunch hour easily, right? Typically. So maybe that's part of why, setting up the infrastructure correctly is challenging.
Great insight. I was just wondering about that dynamic because of what we observed. Thank you.
No, and it's such a long supply chain, so many links as you go down, and it's amazing. It speaks to I think the value and the variability of the supply chain. I think is part of the greatness of you have choice, but it's that double-edged knife like anything. Having choice and sometimes means maybe certain flows, and that's where I think a lot of the supply chain work happening in the standards groups, whether Intel and others. Some of the stuff on maybe SBOM will help, but Yeah, this one hurts a bit today, so yeah.
Yeah, and I think attackers take advantage of that supply chain complexity and the openness that ultimately breeds some of these exposures and vulnerabilities. We've seen a timeline. In fact, we have a timeline of boot kits right over time that have been used in various malware campaigns and malicious code. But Black Lotus was the one that it really kind of culminated in the way that it took advantage of all of this, including vulnerabilities, including the root of trust. What's your take on Black Lotus?
Yeah, no, I think Black Lotus is definitely different than things like the boot hole that I think Eclipsium helped drive some of the analysis of, which was a flaw. You could sort of stack, smash, grub.
Mm-hmm.
Black Lotus, and I won't claim to have done the doctoral dissertation and review. I haven't gone through all the Eclipsium, or I saw Alex Matrosoft publish some stuff a couple days ago. But my understanding is Black Lotus is more like a confused deputy, namely people abusing the mock list variable that the Linux ecosystem had set up for the shim loader, namely how to have a more owner-controlled trust anchor outside of the UEFI authenticated variables, had put the attack code in the mock list. So you had an authentically signed shim, but the shim honored the entries in the mock list, and one of them was your malware. And so he was a confused deputy. He didn't know whether it was a good entry or bad. He was just going through the mechanics. And again, that speaks to kind of the threat model circa 2010. The Linux community said, hey, it's going to be kind of a pain to put a SUSE root, an Ubuntu root, roll your own distro root in everyone's PC. We'll have the Microsoft root for Windows, then we'll have the UEFI CA for everyone else, adapter card vendors, pre-OS, independent software vendors, including but not limited to the shim. And then what shim loads, we'll manage it ourselves, this mock list. And our threat model here is, this is a boot service only variable, and let's assume with secure boot on, bad people won't hang out in the boot service time. Well, bad people are hanging out at boot service time. And so this is definitely one we need to kind of, reset maybe some thinking on the threat model. And then one of the roles I have, since my kind of the hat I'm wearing today is the UEFI standards hat and some of the work with open source, is I run the UEFI security sub-team. And this is kind of just had a conversation with James Bottomley this morning on this, on what can we do with the Linux community on reimagining. Maybe we need to, ACL that class of variable in a different way to other variables. It's great to say, and if I had the perfect answer tomorrow,
right,
pushing updates to the supply chain, oh boy, howdy.
And one of the elements of the attack too is kind of the bring your own vulnerable bootloader that isn't in a revocation list scenario. How do we threat model that, Vince? And what are some ideas you have on how we can combat that threat in the future?
Yeah, I think maybe some of these things have to move upstream, maybe more detection. The OS guys, middleware guys saying you're maintain their own naughty lists, trying to do everything with the firmware managed revocation list. Because firmware managing this is tough, where firmware is resource constrained. There's the supply chain doing the pushes. And I have to giggle because I was in an open compute project meeting. They have a security sub-team, and they're talking about device firmware. There's a standard called SPDM, and how do you know my device and all those other sundry 16 firmwares on my board beyond the BIOS are good. And someone said, well, let's set up a CA and we'll sign everyone. And then they said, and they rattled off like 5 issues. And I was thinking, man, that's the playbook of UEFI secure boot, meaning in a kind of an open ecosystem, having firmware managing trust anchors and revocation is tough. And kind of the philosophy we have in EFI is kind of Occam's razor, namely, do the minimum you have to in the boot environment, right? Because OS guys can service things better. There's a better velocity, a better management experience, but there's some necessary things you have to do in the firmware. But do necessary, but not more if possible. And that even goes to boot performance, right? If you can defer something to the OS, definitely do it. We talk about just boot critical drivers running, So same with maybe this revocation and or detection is something that needs to be pushed upstream if possible. Now you may have a physics problem of, or what do they call Heisenbugs, where you can disrupt the watch or the detector if you usurp this layer. So I don't mean to imply I know the easy button, but thematically I would argue for moving upstream if possible. The Eclipsium, CrowdStrike's, Defenders et al., I think, have a pretty strong bench and reach, and maybe they could provide some visibility into this too.
And just really quick for our listeners, the issue with Black Lotus is that you basically arrive in current state at almost a forever day, because there's no good way to revoke one of those bootloaders without breaking everybody's backup and restore options. And since it's such a large berth in terms of blast radius for that particular vulnerability in secure boot, right now there's no real good way to mitigate that. And so if you look at the actor that was able to develop this for and sell it for $5,000, well, its cost must have been something less than $5,000, right, so to speak, at scale. And it's a fully developed bootkit, fully documented. The samples are on VirusTotal. There's 16 samples plus on VirusTotal. So I'm looking at this from an economic standpoint, since you've been bringing up the concepts of complexity and cost and efficiency and Occam's razor when it comes to what you worry about below. But in my mind, from the attacker's standpoint, right, if we wear that evil hat, I can't imagine other actors, nation state and other criminal actors won't leverage this practically forever day going forward unless we can find a better fix, because without breaking things.
Yeah, no, compat is tough, and I know all of us who enjoys, when you do a BIOS update and BitLocker stops working, and then they say put in your recovery key. People, and this gets back to even what I say about this layer of software. Yeah, when I started DFI, we had all this extensibility. I thought, man, we could do all this cool stuff, value add, and I've come to the realization in 2020s here of kind of firmware is value neutral, meaning when it works, you shouldn't even know it's there. But when it disrupts you, whether you have to read an article about it, giving you some security, heartache, boot slowly, if it's the supply chain, it's hard to use. And I call those the value negative vectors. So part of our mission is to go back to value neutral for people to not talk about it. And yeah, this one that's going to challenge of, do you disrupt folks, and does firmware have to become, quote, more seen? You have to do some updates or some user interaction, which is often the no-no. But yeah, I haven't studied this one enough and the ramifications to have a good opinion on the Lotus, to be honest, today. So I think if I went too far, I'd probably get in front of my skis. And yeah, again, I haven't seen read the Eclipsium report or Matrosov's posting from a few days ago to have the too strong a response. Although I'm sure the audience, that's like top of the news stack, would want to hear some pearl of wisdom. But I think this oyster's just got a little grain of sand right now on this one. So yeah.
Scott, did you have more questions?
Well, I like to think of things strategically as well. And if you look at the chip wars going on between the West and the East, if you will, you look at the sanctions against technologies for other countries that are having a hard time now getting their IT. I just look at this as it's quickly moving towards an economic and socio-political battle space, for lack of better words. And I feel like a lot of the assumptions we've made for the last 20 years in your career need to be kind of fundamentally changed in order for us to build something anew with all this new fab and everything else. But like, this needs to include firmware to build like a better root of trust and a better validation of whether there's malicious components that are still being used coming directly from supply chain versus vulnerabilities being exploited by attackers. That's definitely always going to be in play and has been. But I feel like we're going to start seeing more direct threats coming from the supply chain. I'm just wondering, like, at your strategic thinking brain level with your experience, how do we affect that change across this industry fast enough to matter before it becomes a threat that can materialize, and things go.
Yeah,
boom.
no. I think, and I think we have to honor the fact that some of this is slow moving infrastructure, but that's not an apology or an excuse. I think what we have to do is, the nice thing is, things like how we distribute firmware have well defined, binary encapsulations. Why is everyone building from source, right? One of the things I've been advocating is, if you're doing EFI, can we take the most common idioms in code and distribute it one way through like either a payload or something, and get more reuse? So I can say, we're fixing these 12 CVEs against the upstream this quarter. Just snap the latest, quote, EFI payload. Why are you cherry picking and curating changes? So defragment maybe some of the supply chain. Definitely, such that we have the ability to provide insight into the provenance of some of the low-level components we maybe don't today. I think also new trends in CPU security, such that virtualization-based security, secure core PC, we're leveraging more capabilities in the CPU, because why is something like a DRTM more provocative? Well, did the CPU vendor get that slug of code right? And then they look at an EFI feature and say, did a supply chain of 200 companies get it right? So sometimes maybe moving more to hardware, some more hardware-based security are some trends. Definitely think the world is moving fast, and I think we're living in worlds of exponentials. And exponentials are cool when you're on the front of it and you're ahead of the beast, but when you fall behind in a world of exponential change, or it's sometimes hard to catch up. But I think there's lots of trends happening. So more observability, supply chain, defragment, host firmware, more consistency on how we're doing defenses as we evolve UEFI secure boot, because for post-quantum, we're going to have bigger keys. Use this as an opportunity to rethink, some of the learnings from like the revocation story and others. Use the Black Lotuses and the boot holes as case studies that can inform how we evolve the technology. And then lean in hard on some of the great advances that are happening in hardware security.
This is like one of the most complex crypto systems. I did 17 years supporting DoD. I've worked with a lot of crypto systems, and I look at this as a crypto system. I'm like, the quantum aspect from the math perspective and the memory resource requirements perspective is already a challenge. But you have to protect the crypto system, right? You have to protect keys. Like, there's so many aspects of this that I can't see the human race truly figuring out going forward. But maybe the post-quantum rebuilding that we need to do is a good opportunity to reevaluate the entire crypto system, because you have to make this giant technology push and tech refresh. It would be a great time to really kind of step back and look at it as a proper crypto system versus a vendor system, and say, how do we actually take control of this top down and manage keys and protect from vulnerabilities, et cetera?
No, I think it's right on. I use this as the opportunity. Anytime there's a break, and the key is, the important thing is, don't sort of accrete little changes over time, because then, how do you know they happened? Find a break point. I got to go to bigger keys for this reason. Well, if I'm doing change and I got to roll the big update, let's reimagine in how we do lots of things. Hey, I did a lot of stuff in SMM as reference code because it was easy to explicate in a portable fashion, but really people should be doing stuff that's in SMM today, other places. You're doing a break here, you're changing other stuff. Maybe change those practices or armor your SMM better, but ... I think that's a really salient point, that I think the post-quantum is our opportunity to say, pause, take a breath, look backwards on what didn't work well, and how can we evolve going forward. And then that compat question I mentioned, the market has figured out. So like in UEFI 210, we added this thing called crypto indicators that said, I do Whomper big keys, I do little keys, I do this, I do that. The green eggs and ham on a boat, on a plane, and a train, and then provided a way to say, turn off a bunch of those and say, I only want the big Whomper key, or I want to be compat with smaller, but let the market decide. And then hopefully that policy engine doesn't become what they attack. So make sure we do it right. But I think maybe have to leave some compatibility behind, just like we left MBR boot behind. And maybe that's the business reality for some of this. Don't know though, but that might be the right answer.
I think that's a good answer, Vince. And I want to thank you for your time today, and thank you for all of your work in this area and continue to push forward these security initiatives that are super important to really all of computing. So,
oh, hey, thank you guys, and the great questions, and also the work Eclipsium does, your reports, the rock stars you have on your bench, Mickey, Alex, John, Yuri. Yeah, I think you got a dream team, and I think you're doing a great job by being, outward facing on your research to help the broad ecosystem to have some understanding of what's going on. So,
well, thanks
for
very
that
much.
work. In addition to the invite here.
Awesome. Yeah. Thanks so much, Vince. That will conclude this edition of the Below the Surface podcast. We'll see everyone next time.